Okay, I think we are now live already. All right. Hang on, let me just go. Okay, so good afternoon, everyone. Hey, welcome to our 14. Okay, I think we are now live already. All right. Hang on, let me just go. Let me see again my video here. Okay, so good afternoon, everyone. Hey, welcome to our 14. Okay, I think we are now live already. All right. So I'm hearing a lot of different voices because right now I'm going to be live on Facebook and on YouTube as well. So there'll be different voices coming from everywhere. Okay, so once again, welcome to our MathSifu Quickfire Math Thursday. So it's been really fast. It's already coming to the 14th session already. So I've done it like 14 times already. So ever since we have started in February, yeah. So we have been constantly doing this for every Thursday. The timing hasn't changed from 5 to 8. So the main objective is to help open up this 3 hours time for people to come in with questions or questions that they want to ask or they want to revise over the while they are preparing for their upcoming like revision or whether is it for their upcoming weighted assessment. Okay, I understand that over the past week, um, a lot of the schools has been releasing their exam schedules already. So most of their weighted assessments is around the May period. So it's about I heard dates like May 9, May 12, May 10. Okay, so subsequently the weighted assessments as they come up, they will be the students still take them like mid-year exams, and so does the schools. So there is still a lot of preparation work going on, a lot of revision. Okay, so basically this quickfire, the objective is to basically open up this channel, this 3 hours time for people to actually just come in and to ask questions, whether is it on certain topics that they don't understand or maybe they need some help in their homework. Okay, and right now all of this is being started from Zoom. So from Zoom to stream to Facebook to YouTube, so on and so forth. Correct. So people will be coming in. I'll be expecting people to come in directly to my Zoom meeting so that they can ask questions or maybe they can interact with me over here. But nevertheless, if there are people who are coming in from like Facebook or YouTube, okay, you guys can also interact with me over there as well. Okay. Let me see. I can manage both sides from here. Okay, if there are no questions from the crowd, normally what I will do is I'll just select a random topic and then I'll just like go through as if it's like a normal you can call it a lecture, you can call it a podcast, you can call it like a broadcast, up to you. So I will prefer to make it more freestyle as it is like this because I know that there are people that is doing the same thing and then they have like a preset of list of topics already. I don't want to go into that. I don't want to go into that kind of format because number one, the tutors out there are doing it much better than me already, and they've done it much more established, and then there are much more people over there who follow the same format. So if you're looking for preset topics, feel free to reach out to those. Okay, I want to make this communication a more freestyle one so that people can just come in and really have a direction and have an intention of finding out what they need to work on. Okay, so they come in with their questions, I will answer their questions. So it doesn't, I don't want to make it like a fixed format. So anything come, anything goes. Okay. Whether or not other people coming in, I don't really mind that much, to be very honest, because ultimately I'm also documenting all of these things, all of this to be, to be documented, and then in the future I'll be segmenting them to different topics and small content segments. Okay, so ultimately it is still part of the documenting journey. So if there are people coming in to interact, all the better. If not, I will just take this as a self-documentation of the entire like math content that I'm going through. Okay. So let me also take this time to just push it out to my social media groups. Okay, so for the social media wise, right now, I have the social media channels hasn't changed that much. Number one, I have my Discord channel, my Discord server. Okay, which serve the same purpose like for people to actually come in and to interact with me. So for people who are using Discord, you all can reach out to me to get the link. Okay, that is one. Number two, I also have my two Telegram channels. Same thing for you guys to ask questions, and I'll be posting content articles as well. So that is my Discord, and then on Telegram. Then after that will be more on the what after that will be more on the WhatsApp group. WhatsApp group is still, I want to make it a bit more private. I'll make it more private. So I don't really want to make it too open because due to privacy. So this WhatsApp group is being started by a few secondary school kids. So they pull me in. So okay, so I'll just be in there as and when. Okay, so apart from that, my website, my email address are all open. So if you guys need to like reach out to me or anything, feel free. Or if you guys are looking for like tuition services, I can do that as well. But like I always mentioned in my previous streams that my time slots are limited, and if there is a chance, I'd rather not take your tuition. I'd rather not take your tuition because ultimately it is still the student's responsibility to take charge of their own learning and to take initiative. So if there is an alternative way for students to pick up alternative methods to do self-learning instead of depending and relying on a tutor who knocks on their door every week and then just to change their homework or to assign homework, personally I feel it's not a very effective method to in the long run, unless you tell me that today you are studying just purely based on exams, then okay, fair enough, then we can help you to work the best out of your exams. But if you are taking learning as a lifelong thing and you really want to really improve and to to own the skill of learning, I think that's quite important. Own the skill of learning. So I'd rather open up, if that's the case, I'd rather open up more resources and channels for you guys to tap into. Okay, with the use of technology and like AI, now we've got ChatGPT and all that stuff, there is so much more we can do. So of course, over the past week, I had also been tapping into the power of AI, like things like ChatGPT, things like Midjourney, to help me to to generate ideas, to generate some content post ideas as well. So, and it helps me accelerate on what the plans that I have for myself and the company. So ultimately, like I always mention, academics is just a medium. Academics is just a platform and a surface level that shows and illustrates the habits and the psychological patterns of children. I feel that tutors can come in to address the academic concerns, like maybe careless lah, conceptual errors lah, and all these things. But in fact, what lies within and what is underneath all these academic issues are psychological barriers and issues that is yet to be found, and it remains unfound because normal tutors don't really look into those. Number one, they don't have the knowledge to look into those, and number two, maybe they don't have the courage to actually open up these psychological issues, like things like self-confidence, self-esteem, trauma. In fact, all of these are actually non-academic concerns that will show in your academic results. So personally, for me, I take academics as a medium. However, I feel that it is more important to address these psychological concerns first And once these psychological concerns gets addressed, get solved, okay, the academic results will generally improve. Whether or not is there any academic help that is being roped in. Of course, if both psychological and academic help comes in both together, then okay lah, then the more help the merrier. Then these children will be able to improve in all ways. Okay, but however, between the two, what is more important is actually the psychological part. Because if you, no matter how much a child can study, no matter how much a tutor can teach and teach and teach every week, or whether they go to school every single day, if they, let's say they already armed with all the knowledge that they are ready to go for the exam, they understood everything that's required for the exam, then what if one day the exam day comes and maybe due to anxiety, due to stress, due to the lack of emotion management, he or she goes mind blank, or maybe have anxiety or panic attack. So these are things that we cannot really prevent and to solve on the spot. But however, this is a result of the lack of management and the lack of addressing these psychological concerns from the very beginning. These incidents could have been sprouting ever since maybe a few years ago, or could be weeks ago, or it could be many, many years ago, or even when they are born. So all of these small incidents are small trigger points that actually plant a seed into the children's subconscious mind that will affect their performance later on. So a lot of academics in academia industry don't really look into this, which is very unfortunate, and I wouldn't blame them, even though it's unfortunate, but it is because they lack the knowledge and they don't have enough the expertise to actually go deeper into it and to have a deeper analysis and to really pinpoint on what can be done. Okay, so in fact, this is what I really want to venture into at the end of the day, in the long run, ultimately, because if we can help to increase and to improve the child's self-esteem or confidence, or maybe in terms of how the children communicate with parents, how the family bonds and cohesion. Actually, in fact, all of this will also impact how a student will perform academically. So, because when we are all born, we don't have any knowledge inbuilt. We are all born like a white sheet of paper. We know nothing. We know nothing at all. So ultimately, everyone is born the same. Everyone is born the same. So it is how the environment that these children are being exposed to that shape them. Oh, what is right, what is wrong, what is appropriate, what is not. So it is about addressing these issues, these kind of subconscious beliefs and mindsets that they have even before they enter education, or even before they start to learn something. I feel that these psychological aspects are something that it needs to be looked into, and looking forward into the new, you can call it the era, you can call it the new century or the new age, especially with the born of AI. The mindsets will shift even more for children as they grow up. They are born with TikTok. They are born with Instagram. Snapchat is already a past already. Last time when I'm a millennial, share a bit more. I'm a millennial, but Snapchat wasn't around when I was born. So I only came across Snapchat when I was like early 20s. So when it comes to Snapchat is, so in my perspective, Snapchat has come and gone. That is how rapid it was. So nowadays, children are born with TikTok. They are born with ChatGPT. They are born with Snapchat. Maybe Snapchat they are still using. They are born with Discord. Discord is a big thing. They are born with much more extraordinary tools that's being created by technology. So naturally, the mindsets and the environment that shapes their initial thinking and beliefs and values will definitely change and be very different from where, like, as compared to how I was born. Perhaps people who are watching this today, maybe people who are older than me, or maybe who are younger than me. I don't know. But you can see that the change in the era and the change in the mindset is going to be even more, the cycle of change is going to be even more and more rapid. You can say that me and my parents, we have the same mindsets, because the cycle of change in terms of how the mindsets shift we are still within the same cycle. We are still within the same cycle. But what is happening right now is that parents today, so it could be my schoolmate who just gave birth to like 2 daughters, or maybe it could be and their children already, and it could be some of their kids already. So in fact, right now, new parents and their kids are in a different cycle. That is the thing. That is the problem. That society is still scratching their heads and thinking how to solve them. Because the cycle is getting too fast. So for us and our parents, we are in the same cycle. But for us and our future kids, we might be many, many cycles behind. Because everything changes so fast. The information that they bring in, that they absorb in, is going to be very, very different. So in fact, parents nowadays are finding themselves more and more troubled and having a lot more issues about thinking about understanding their children, because their children are already in so many, many cycles later. Unless you're talking about a parent who is constantly following the changes, keeping up with the trends and technology changes, and having the mentality to actually think, hey, what is up for the years to come? In fact, we don't even talk about Snapchat. We can even talk about things like crypto or Bitcoin, cryptocurrency. Cryptocurrency right now for us is like, it came, but it left. Again, back then you're talking so much about Bitcoin, Dogecoin, and Ethereum, and all that stuff. It is still around. It is still around, but the hype has already been like gone. Yes, it's still around, but we don't really see much being talked about it as compared to that period where it was crazy all over. So crypto, it was thing that came and left. Snapchat came and left. Okay, so in fact, even just these two very recent topics to us, it is still something very new to kids nowadays. So the mindset shift has been too rampant. Okay, so in fact, for me as a tutor, I also constantly struggle with understanding the kids sometimes about what they think and what do they do in the normal lives, because I only see these duties once a week, but the parents see them every day. But yet the parents don't understand what the children are doing, because the children are just doing too much things and too vibrant things. Like, for example, nowadays, the kids are actually into Roblox. If Roblox is something that is like it's like a Second Life. If you guys still know Second Life, and those of you who are in the same era, you know what Second Life is. It's like a Second Life, but for kids. It's like a Second Life plus Minecraft. You put together, you get Roblox. Okay, so back then, Second Life was still a very abstract thing, because back then computers are not so advanced to process high amount of graphics. That's why Second Life and being able to emulate real life environments in the computer behind the screens is something still very difficult. But now today, with VR, with AI, and with higher graphics, all these are getting even more and more lifelike. And to be able to create the kind of lifelike environment, Roblox came in first. In the future, will the characters in Roblox and the things that is able to be done in Roblox, will it be more lifelike? Will the characters and avatars be more lifelike? Yes, definitely. They will be more and more like human. So when people who are playing them, like holding their devices and holding them and playing them, they are literally looking at themselves in the virtual world. That is going to be the future. And in the future, also, when we look into the perspective of the Chinese metaphysics, where we talk about 2024 being the new era of 20 years, the 下元 2024. Okay, if you're interested, you can go and find out more about it. In this new era, when we talk about, it's called the fire, 就是 they call it the 离卦. The 离 stands for 火. So in this fire卦, this whole fire, these 20 years, right, what will happen is a lot of things, what will thrive? The virtual environment will thrive. The personal well-being, people who are industries who are reaching out in terms of personal well-being will thrive. People are now looking for a higher level in terms of the Maslow hierarchy of needs. People are looking for more for self-enrichment. People are looking more for spiritual enhancement, spiritual well-being. The basic needs are already met. It's too simple to hit. It's too simple to achieve. Now people are looking for more. So in the next 20 years, what will thrive? AI environments will thrive. That's why when ChatGPT came about, it was a hit. It's like a lot of people commented that it's like a new thing since the internet. In fact, I will say yes, because I will outrightly say if today you are of any age, no matter which industry you are in, no matter which age you are in, whether you are studying as a student or maybe you're already working in a corporate life for the past 20 to 30 years, if you are not using AI, you are going to be obsolete. That's it. You are going to be eliminated because people are using AI so rampantly that I had witnessed it firsthand about how ruthless, I use the word ruthless, how ruthless that people are using AI. It's crazy. It's like AI is like people are already using it like as if it's a second nature. It's a second brain already. Because AI has no emotions. It helps you store data. It helps you process data. It helps you generate images. It can actually process your thoughts for you. Okay, so I've seen it myself. I haven't reached the extent where I use it extensively for like image generation and all that stuff because I'm a math tutor. I don't really need image generation and stuff unless I'm doing like content posts and stuff. But I've seen how my other peers do it. Like for example, I have a friend who is doing SEO. Okay, so he opened up the computer, go to ChatGPT and say, write me an SEO article about SEO. And then immediately within seconds, the ChatGPT start doing it. So lines and lines and lines of lines gets generated. It's without a second thought. AI can process things and generate content without second thought. Maybe all the information is all in the cloud server already. All we need is to just go in and get them out. And it's within seconds, it's going to be created right before your very eyes. And all the content are being professionally written. And then the next command from the ChatGPT, from my friend to the ChatGPT is that just 3 words, make it shorter. Make it shorter. That's it. And then another more condensed version of the SEO article about SEO gets generated. It's crazy. It's like because nowadays with the use of such ChatGPT and this tools, right? The thing is that people are getting more and more lazy to think. I'm sorry to say, but yes, lazy to think. It's not a very good sign, but it has forced us to not think and to just grab anything within our means. Just grab anything within our means. So I often tell my friends, I often tell my peers, I often tell my students, it's not how you can achieve now. It's no longer the how, it's what you can achieve now. Because if you think of what you want to achieve, you can literally get it without second thought. There's no such thing called no time. There's no such thing called I don't know how. There's no such thing called I don't have the connections and resources. No longer. We are past that era already. Because back then, when we wanted to do research, we don't know where to start. So we go in Google, we type in our stuff, and then we start looking through tons and tons of articles, and then we think, okay, this one can use or not? That one can use or not? We have to do a lot of processing on our own. There's a lot. We have to process all these different sources and articles, and we are also being taught how to distinguish sources, how to determine whether the source is credible. We had to go through modules, university modules on how to distinguish articles, whether they are real or fake, reliable or not, credible or not. Nowadays, don't need. Obsolete already. Totally don't need already. Because, bam, you ask anything in ChatGPT, it's curated information just for you. So it's no longer about it's no longer about how you can achieve. Because back then, the method is difficult. The how to get started is difficult. No longer now. Now it's about what can you achieve. If you want to achieve something, put in ChatGPT, they teach you how to do it. Everything. Every single thing. So if people are still thinking about what's AI, what's ChatGPT, how can it help me, how will it affect my job, I'm sorry, you will be obsolete already. It's, for me as a math tutor, do I see it as a threat? Yes. But do I see it as a strength? Yes. I feel that instead of being fearful and being threatened by AI and fearing that AI might eliminate my job, I would take it in a different way and say that how can AI help me in my job? Okay, so AI is here to make friends with us. AI is just a bot. It is just a bot. It doesn't have any emotions, no feelings, no nothing. It won't have emotional damage. You won't care that. It will just curate facts and theories and information for you. So feel free to use them. Okay, so for me, how I have been using it is for me to create my own posts, to think about my syllabus, to think about how I can better understand children, understand parents. And right now, I'm also coming up with different content articles for parents to actually help them to better communicate with their children and to understand about their learning habits and styles and psychological patterns. Okay. Ultimately, I do hear from some sources there are AI platforms that is being focused on solving mathematical equations. Okay. Will it affect me? No. To be very honest, no. It will affect those people who are out there who are coming out with preset topics and teaching them as per schedule. It will affect them, not me, because I make it a freestyle. Yeah. So in fact, I will want to that's why I want to maintain it like a freestyle method so that I will remain relevant and reliable, because it is still something that is still people still want the face-to-face touch. Can the AI replace a very manual teaching process? Yes. Yes. But ultimately, will it be achieved? Yes, maybe not so soon. The good thing is it may not be achieved so soon because there's so much mathematical theories out there, so much to learn. I know that AI can do it much faster, but in fact, AI can only store what is being solved, can only be used to store what is being solved and understood by the majority. Because who inputs the intelligence of AI? Humans. It is still humans. Even in the example of, if you guys go watch the movie called AlphaGo, where the AI go and compete with the so-called the most powerful Go master, that means the Weiqi, they play. So the Korean master played with AI and lost. Remember that movie AlphaGo? You guys got the time, go and check it out. Yes, but how did AI able to learn itself? It is also being manually fed in thousands and thousands of matches of Go into the AI system, and the system go and learn, okay, this is good, this is not good, this is good, this is not good. So for in the industry of mathematics, will the same thing happen? Yes. However, how far will it able to reach us? Not so soon. The current ChatGPT is not capable in solving math yet. Complex stuff, I would say complex stuff. Okay. And previously, I understand that there are articles that mention that, okay, there are people who bring in to use ChatGPT to do a PSLE paper. and then it failed. Okay, and then the ChatGPT failed very badly. Okay, and then a lot of people mock ChatGPT not able to do math. But I would say, not true lah. The AI can learn. AI can learn. So once they see the paper, they know what to do, and then next time they're able to process the same way. But however, will it be able to replace the human thinking of doing the maths paper? Unlikely. Unlikely. Because Singapore math has a very unique approach in terms of doing mathematics. Drawing models, drawing diagrams, showing items visually is still something very unique to Singapore, and in terms of writing manually. Can it be replaced by AI? Maybe in the next 50 years, but not now lah. Not now, because it's still Singapore math is still a rather unique system. So I'm not very worried about that, and that's why I'm still confident that you're still here. Okay, enough chatting for today. I think we have chat about 40 minutes. Do I need to continue chatting? I haven't do any maths yet. I'm just gonna chat about AI and stuff.
So what are you intending to finish?
Huh?
What are you intending to finish?
I'm still gonna finish at 8. I'm still gonna finish at 8.
Then you can,
I can still continue, right? Okay. Because ultimately, if you guys really have any questions, you all can just come into the Zoom meeting straight, or you all can just look through the social media platforms. Yeah. Okay, ultimately, I'm just going to continue like ranting. No, not really ranting, but I think these are still relevant topics that is to be shared ultimately, because AI has came in too fast. One launch of ChatGPT got the whole world using it already. So we need to be on our feet to actually update everyone, to share about what we feel and how our company and myself can sustain in the midst of AI. I think it's still quite important, quite relevant still. Okay. So of course, if you guys got any specific math topic that you want me to go through, yes, I can do it. Let's go. We can still do it. So I was still typing halfway to launch to let my social media channels know. I'll keep ranting about AI and stuff. Okay. If that's the case, I have Okay, so if that's the case, if today I actually have the idea of going through this topic called logarithms. Okay. Or of course, if you guys, like I mentioned, if you guys have any specific topic that is not what I mentioned, and you guys want me to go through, by all means, let me know.
All right, good afternoon, people.
Okay, maybe I can. So maybe any topics you want me to go through today? Don't have. I don't keep ranting though.
Okay.
Really? Really? Nothing? Or should I go through primary school topics? Is it? 9、6、7、8。I think my Quickfire has becoming more and more like a 3-hour chat session already. I've been ranting for the past half an hour already. Huh?
Is it enough?
It's never enough. It's never enough. It's never enough. Okay. So in fact, one thing is, okay, I got a few ideas lah. Maybe you all can let me know what you think. Okay, number one is on logarithms. Logarithms, okay. Oh, I haven't shared my screen yet. 现在做的越来越随性好像。Okay, where's my Zoom? Yeah. Where's my Zoom? Eh? Oh wait, I can't share screen from here lah. Oh my god. Is it? Okay, here. Okay, great. Okay. I think you guys should be able to see my screen now. Okay. So the idea today is I want to go through on logarithms. That's one. This is mainly for Sec 3 and above. Okay. For Sec 2, that means for this is for A max. Set 3A Max, you guys are going through this now. I understand that right now for Sec 3E Max, you guys are going through congruence and similarity. That means how do you determine whether two triangles are congruent or similar, and what can we do with it? So this is congruence and similarity. So these are Emax. Okay, what else? For Sec 2 and Sec 2 right now, they're also touching on similarity as well. So I'll just quickly run through over here as well. Sec 2. For Sec 1, right now, I haven't gone through their topic yet, but if I'm not wrong, it should be on speed. On speed. Okay. So this is for Sec 1. Okay. In fact, I know that there will be people doing primary school subjects as well. So for primary school, I will want to touch more on mental arithmetic. If I were to ever touch on primary school topics, it's mainly through problem solving and model drawing. That is the main. And then maybe talking about fraction word problems where we have like different techniques to look at, or even going down into detail in the 3 different problem sum types: total unchanged, difference unchanged, one quantity unchanged. In fact, are they any easier than secondary school max? No, because primary school have their own difficulties. So for those of you who maybe you are a secondary school student and then I go through a primary school question and you guys, yeah, this one's so easy. It's not very fair to say so, because each of them have difficult in different areas. So let's be fair about this. Okay, but in fact, all of these problem sums and all ground for mental arithmetic. If your mental arithmetic is not good, you can forget about doing all these difficult sums already. 那是怎样啊？那些no, I don't know. But they have stuff.
Who left it?
I have no idea. Oh,
Someone gave it to them.
yeah.
Do you want that?
Oh, so we just received a mysterious package. I thought this was being left by my wife.
I thought it was you.
I thought it was you.
Why would I be doing that?
Yeah, but I don't have all these. What is MEP? Oh my god, this is interesting.
Right?
I have no idea what this is from. I thought it's just math paper, right?
I didn't take them here.
Oh, could be people who know about pop-up event. Is it?
Then what? That means someone must have given it to you.
Yeah. So we receive interesting notes from like this.
It's a whole stack of questions.
It's a whole stack of questions, and I have no idea where they came from.
Okay, let me find the source.
Yeah, you go and find
I
the
think
source.
you need to find the source.
Yeah.
This is a very serious person here.
I think okay, the materials are good. These are math stuff, but this is our pop-up event actually work. Interesting, Yeah, go and check. Okay, to update you guys on what's happening, right? Because yesterday on Wednesday, we actually did our very first pop-up event in our office. So what we did is that we created our own QR code, okay, and then we allow our people around here to go and scan and then enter our website to find out more about us, and at the same time, they can also send in their children's assessments and screenshots to us so that we can access it for free. That means we perform a free assessment based on what I mentioned earlier, which is to identify their psychological patterns and learning habits, so on and so forth. So the event was pretty okay because we did it during lunch hour. So there were people walking around, asking more about us, connecting a bit more. So we made some new friends along the way in this office. So it was quite a fun event. So in fact, we are going to do the same thing at a couple of other Just Code centers in Singapore. Okay, so we are already planned for 3, and we are going to launch another 2 more. So that will be a total of 5. So subsequently, you guys will be able to see us at different Just Code outlets. Okay. Then today I saw this whole stack of notes over here. I thought I thought it was being done. I thought it was being left there by my wife, but it's not. Okay, apparently it's just a whole bunch of like max questions that it was prepared by none of us. So my wife went to check what's going on. So okay, I hope there's a positive result. And at least this shows that our pop-up event was successful because there are people giving us free resources. So okay, I think that's a good thing then. Okay, back to our content. Sorry for the little interruption because this is actually kind of interesting. Okay, let me just do my Zoom broadcast again. Okay, so back to the topics that I want to go through. Like I mentioned, these are the few that I want to go through. If you guys have anything that you guys want to, to let us to tell us more, or to let me go through, you can let me know. Otherwise, I'll just start off with this. Okay. These two I can lump together because it's on congruence and similarity. So based on different things, okay. Logarithms is one. Speed, maybe if there's enough time, I'll run through. Otherwise, I think we can leave it for next time. Mental arithmetic is something I'm still considering if there's a time, but not all people may appreciate it at this point in time. So yeah.
I'm just a bit thinking that it's ours because first of all it's maths. Second of all, it says MPP, so he thought like our typo or something. But apparently not. He's saying it's been there the whole day since morning, since 9 o'clock in the morning when
Hey, then we take it lah.
No, don't so bad lah. Why if somebody comes and claim later? So I don't need to hold on to it first. If nobody really until last minute nobody claim, then they'll give it to us.
So it's been left on their desk.
No, on the printer.
On the printer.
Yeah, it's at the printer.
And thought it was ours.
Yeah, because whole day nobody claimed. So he thought like it's us who press like print.
We printed the stuff.
Then yeah, correct. Then never collect. Because it was obstructing everybody else who wanted to use the printer.
Oh. Interesting. That means there are some other people and companies around here that's doing math, right?
I said no, there are no other
Education company?
companies here that is doing anything related to education except us.
Huh?
That my guess is the person print for personal use lah. Charge.
Charge company. Okay, cool.
It's like at one page, one.
It's single-sided somehow. It's single-sided somehow.
That's why.
Crazy okay, can, never mind. If they want like I said, finders keepers, losers sweepers. Okay, if nobody, you guys heard it, if you guys know, but if nobody claims ours, I just gonna coop it, man. I know that the questions, I just screen through the questions that they are quite easy actually. Those are quite elementary questions.
But
Lower set questions.
But the thing is, they come in like unit form, so that means it's from some fixed sources.
It could be SAT material.
Correct.
SAT test material. Because it was like calculating 25 times 4, like, do you need how many 2 seconds for that?
You ask them?
So I don't know. I had no idea. So okay, Ken. So okay, back to the topics here. I will not go through speed and mental arithmetic. In fact, for mental arithmetic in the future, I want to launch a workshop on it, but we leave it to next time. Okay. So with that, let's start on logarithms. Okay, so for logarithms, something new, it is still relatively new, even though for people who are already 15 years old, then the first time learning about this thing. Okay, but in fact, it's to investigate about powers. Have I had to go through logarithms before? No, right? No, right? Logarithms?
It's the log thing, right? Log thing.
Log thing.
The log mower that one.
The 2 log 3, 2 base 3 something. No, okay, can. My wife verified that don't have. Can. So
I never see that thing.
The log thing.
Yeah.
Okay, can. Then I can go through logarithms. Yay, okay. Logarithms, I would say the reason I choose logarithms is because have or not? Please let me know. People on Facebook and YouTube and Zoom, please, if you all got it's like if you all really see me got repeat your topic, please let me know. But I don't mind repeating also because this topic is easy. Okay. Okay, but nevertheless, it's okay. It's all right for us to do some revision. If I want to stack. That's all. Okay. Okay, so logarithms. Okay, logarithms is all about investigating powers. So for example, let's use a most classic example. And this is also the most simplest way for. And the most simplest way to remember logarithms and how is it being used. Number one, logarithms is always about powers. I just use these two pointers, right, to go and solve almost all of my logarithm questions. So number one, log is about finding the power. Or some people say finding the exponent. The exponent is probable, finding the exponent. Okay. And number two, this is the first thing I remember. And second thing, 2 cubed equals to 8. These are the only two things that allow me to solve through almost all of my logarithm questions. Okay, why 2 cubed equals to 8? Because we all know 2 cubed is 8 lah. But however, how do we put it in the log format, the logarithm format, such that it is in the correct place and the correct position? Okay, so we learned that 2 cubed is 8. Okay, so in logarithm format, there are 3 components, just like this 2 cubed over 8 thing over here. There are 3 components. Okay, number one, this will be the base. This is the base. Okay, number two, this is the exponent. Okay, which is the power lah. Most of you who are still remember it as a power, it is still a power. Okay, and the third thing is called the argument. Normally, people just casually say the number, the answer, the number, the answer. Not very professional to say so, and the answer can mean a lot of different things. Okay, so let's use a proper term to standardize on this one. Okay, so the first thing will be, so how do you write it in a logarithm format? It's always log base 2, then you write the argument first, then you put the 3. Because remember, logarithm is always about finding the exponent. It's about finding the exponent. So this is the exponent that we are looking for. Okay, so and of course, visually, I'm a visual person. I want to know how can I better remember this. Okay, how can I better remember this? So I always remember, because I know 2 cubed equals to 8. This is how I say it. 2 cubed equals to 8. This is how I remember it. So I always remember 2 cubed equals to 8. This is how I remember it. Okay, so you can try it for yourself. Okay, for those of you, you can try for yourself. For example, I say 3 to the power of 4 gives me 81. So in using this exact same format, how would you write it? How would you write it? It will be log 3. You can always put the equal sign first. 3 to the power of 4 is 81. This is how you write it. See, I always go by this loop format. So 3 to the power of 4 gives me 81. Okay, so this is the most basic thing that we all must know. Okay, so once we understand this basic format, I'm going to leave it to the side, and then I will show you some interesting facts that is based on this, which is very important. We always overlook all these basic things, but in fact, these are very important milestones as we learn logarithms. Okay, so if we learn that, I'll still use the 2 cubed equals to 8 thing because that's my most iconic example. I thought it's the other guy who knew that I'm doing math, he put the math here. Meow. You just manifest and nobody takes it, huh?
Nobody takes it, nobody takes it, nobody takes it, nobody takes it.
Okay. So going back to our example, log 2 8. I just said log 2 8. Log 2 8 equals to 3. So 2 cubed. This just means 2 cubed equals to 8. So what are some interesting facts over here? Okay, very important. Okay, I'm going to switch the two places here. Okay, so So on the left side is what we learn in terms of the power. So 2 cubed equals to 8. This shows us that log 2, 8 equals to 3. Okay, this is the first thing we know. So for example, if today I have 3 to the power of 1. So what does 3 to the power of 1 give me? 3. Straightforward. So how do we write this? Log 3 equals to 1. Correct? Because 3 to the power of 1 gives me 3. Okay? So, in fact, what can we derive from this? It's very important to see what is the derivation that helps us to solve these kind of problems and to identify the special property. So, anything to the power of anything, anything to the power of 1 gives me anything. Okay? So, I imagine I just write this. Anything to the power of 1 gives me the same thing anyway. Correct? So, what does this give us? This gives us to the first property. That means what? Anything to the power of log AA, that means where I write A, this A refers to any number. Any number. If the base and the argument are the same, base, let's say again, the base is equals to the argument. The result will always be 1. Always, because A to the power of 1 is A lah. Anything to the power of 1 is anything lah. That is the very important fact. Okay? So this is the first thing you need to know. Okay? Number 2. Same thing. Let's use the word anything. Anything. Okay, I don't use the word anything, I use whatever. Remember that anything and whatever drink? Okay, not funny. Right? So, if I put any number in the base to the power of 0, what will I get? Anything to the power of 0 is 1. Okay? 1 million to the power of 0 is still 1. Therefore, what can we write over here? Can I say that? Because it's anything to the power of 0 is 1, right? So, what does this tell us? Log A1 is 0. Why? Same thing. A to the power of 0 gives me 1. So log whatever to the power of 0, it gives me 1. So this is the second thing I need to understand. You see, ultimately, from the starting until now, we are still using the same thing. Still, it is still the same thing. Okay? Can. This is the second point. The third point. Now, here comes the interesting part. Now we are done with like the zeros and ones and all that stuff. Let's continue. I'm going to use another example. Okay? 3 squared is 9. This is something that everyone knows. So if I were to put it in logarithm format, how will it look like? Log 3, 9 equals to 2. Yes, correct. So in this case, this is something that we already know. So if this is the case, can I also say, can I convert this 9 to 3 squared? Okay, when I convert this 9 to 3 squared, what happens is that it is still equals to 2. Because the value doesn't change, right? The value doesn't change. Oh. Okay. The value doesn't change. The argument doesn't change because 9 is still equal to 3 squared. And so what happens is that, do you see that do you remember that we said that log AA is 1? If the base and the argument is the same, it's 1. So what can we say from here? Do you see that actually if I bring the power forward, it's actually 2 multiplied by log 3, which is still equal to 2. Because this thing is 2. And then this one is 1. Therefore, it gives me my 2. Okay? So how can we help us? How can we remember this and what does this derive? If you have a log A, X, B, let's say you have this. It could be any number. The base and argument may or may not be the same. Okay? That means is also equals to B log A X. Technically, we can bring the power to the front and take it like a multiplier. Okay? Let's use another example because in this case, 3 squared is 9. This is quite straightforward to see. Okay? So I use another example. So let's say we have log 481. Okay? This A and 81 are not related. But I know that log 40 is 3 to the power of 4. Right? So I can bring the 4 to the front and call it 4 times log 43. Because as I bring the power to the front. This is correct as well. And then from here, we can go and solve for the values and things like that. How to solve for the individual value, I'll teach you all later. Okay? But we need to know the basic forms first. Okay? So in fact, that will be, let me think, is there anything else? Base. I'm thinking, is there any other conditions that I have left out? Okay, one more. So in fact, all of these are still considered the basics, like the basic rules of logarithms. Okay, so when we are done with the rules, in fact, these are the rules already. Okay, so this is the, I just highlight them again. So this one, and the basic, the basic way of writing the logarithms, which is this one. So I went through 4 things already. The basic form of writing the logarithm function. Log AA is 1, log A1 is 0, and log AXB equal to B log AX. Okay, so these are kind of like the rules, the basic rules. Okay, so all of these, right, are under this whole chart, or you can call it a table of logarithmic laws. Okay, it's like a law. You can call it rules, you can call it laws, log laws. Okay, so let's compile whatever we got again. So this is log AX equals to B, which means A to the power of B equals to X. This is the first thing. Number 2, log AA is 1, because A to the power of 1 equals to A. Number 3, log A1 is 0, because anything to the power of 0 always give me a 1. Number 4, log AXB is equals to B log AX. Okay, as the power comes to the front. Okay, the last thing I wanted to talk about here, in fact, there are a few more where it involves about like operations, or like the 4 operations, the add, the minus, the times, the divide. I'll go through that one later. I want to talk about this one. This one, even though it is being listed in school, they teach you towards the end of the laws. But this one I want to talk to you guys first. This is about the change of base. So imagine if today I have log AB, okay, is equals to 1 over log BA. So what happens over here is that the base, the position of the base and argument changes. Okay, the base and argument changes. Okay, let me show you guys an example for this one. This one quite interesting. Okay, I'm going to show you guys what it means. Okay, so using the same example just now, 3 to the power of 4 gives me 81. Okay, so that means I want to, if I want to write it in logarithmic format, so it's log 381 equals to 4. So this is my, so in this case, I want to, okay, let me just put it in the proper format then. So log A, so A is 3, B equals to 4, my X is 81. Okay, this is what I'm looking for. The base, the argument, and the exponent. I put it in this case. So this is in the form of A to the power of B equals to X. Like that. Okay, so in this case, how do I write it in a log format? So it's log 3 to the power of 81 equals to 4. Okay, so this one we are still quite okay there. So imagine if today I tweak it around. I say log 81, 3 equals to how many? Okay, so here we know that 81, 3 from the left side, we understand that 3 to the power of 4 gives me 81. And this is what we are supposed to get. So now, if I were to use the same format into base 81 instead, how will it look like? That means it's 81 to the power of something gives me 3. Is the value going to be 4? No, the value is not 4. It's no longer 4. How do we solve for this question mark? Let's say we don't know what this question mark is. So 3 to the power of, so 81 we know, okay, we know it's 3 to the power of 4. So we write down 3 to the power of 4 question mark equals to 3. And then we know that it's 3 to the power of 1. So 4 times question mark gives me 1. Question mark equals to 1/4. What does it mean? That means this value is goes in here, which is 1/4. Okay, and 1/4 is exactly the reciprocal of the 4. These two are reciprocals. And therefore, this stands. Okay, and this has a special name. It's called change of base law. Okay. So basically, you can easily switch the bases, the position of the bases and arguments by putting a 1/, or the reciprocal of it. This is very important because subsequently, and there are too many questions, right, that actually test you on this one, whether or not are you able to see the change of base. Okay, this is the 5 basic. I haven't talked about the addition, subtraction, all these things. Haven't. Not yet. Let's get the first 5 basics down first. Okay, moving on. Now that we understood all this basic stuff already, let's talk about how to solve it with the calculator. Okay, calculator. Okay, many a times the answer may or may not be a whole number. There may be a bunch of decimals, it may be a fraction or whatsoever, but we don't know. Sometimes they give you a very odd number. They won't give you very nice numbers like, okay, 3 to the power of 4 is 81. Then, okay, so therefore log 381 equals to 4. Very rarely they will give you such a nice thing. It's such a nice thing. Okay. However, I missed out one thing just now, which is on it's also an extension of change of base. Okay, let me tarik a bit. Okay, the 6th thing when it comes to the basic law. Okay, so just now I got number 6. Okay, so this reciprocal thing, because this is a special case, because I'm talking about log AB and log BA, because they are just switching around. That's why it's just a change of base. However, this base, right, can be switched to anything else. Okay, give me what it means. So log AB equals to log B over log A. And then suddenly a C appears. How does this C appear? This C shows that, right, this C can be any number. This C can be any number. It's like the general case of this thing. So this C can be any number that we desire, depending on what the question wants and depending on what we want to do with it. Okay, so just need to know that the B goes to the top, the A, which is the base, goes to the bottom. So the B and A can be separated into two different arguments with the new base called C. This C can be any value, literally any value. Okay. Canva. Yeah. Okay. Small intermission. 我也是忘记了。
讲 3 hours ago。
呀，我刚换的。我刚换。我就是忘记我要换咯。Let me. And one guys. Okay. 028937。Okay, can back here. Okay, so back here. So where will be? Oh yeah, log B and over log B over log A. Okay, for log B over log A, this one I would say quite important. I would say it's something that is more rarely used than the change of base itself. That's why I didn't mention it just now. Okay, but how does this come about? This change of base is putting the value of C to be B. Then you see the whole thing switches. Okay, let me elaborate on this a bit more. I say log AB equals to log B over log A. This C can be anything. So imagine today, I make the value of C equals the value of B. So what will it become? It will become log BB over log BA. And we know that log BB, because the B is the same thing, this one becomes a 1. And therefore, it's 1 over log BA. This explains and accounts for the change of base log. It's just that right now over here, I used an example to actually illustrate to you guys why is it like that. But the proper, not really the proper, but the logarithm way of explaining the change of base is like that. Okay, I rarely touches it, but I always share my duties. As long as you're looking about change of base, is 1 over, it's the reciprocal. That's it. Can move on already. Okay, so the change of base is there. The change of base is there and is very rarely being used, but we must know that it can be changed to any base that we desire. Any base that we desire. We can put in a base there and then we can call it whatever we want. Okay, so now back on to the calculator skills. Calculator. So on a calculator, how do we evaluate a certain value? Okay, we cannot, on our calculator, we cannot put in like, log something, where the base is something, argument is something, then it gives me an answer. Okay. No, as of current exam approved calculators, no, it doesn't have this function yet. Okay. I hope that this function don't come out because it kind of make people dumb because people don't even think about it anymore. Okay, so calculator, why do I need to go through this log change of base thing before talking about calculators? Because in a calculator, you will need this exact skill to find out what you're looking for. Let's use an example. Okay, so let's say I have I use the same example, 381. So from here, how do we key into the calculator? Okay, basically same thing. I can put a number here and put log 81. Then put a number here, 3. So this number in the box can be anything. However, what is showing in our calculator, right, It's only one button called log. It's only one button called log. Okay, if you guys take out a calculator and see over here in this screen, there's only one button called log. What does this log stand for? It is just exactly the 3 letters that you see here, but then there's no space for you to write the base or anything. So what does this log means? This calculator log, okay, I'm going to draw a box here. Log stands for log 10. Okay, in short form, it's called LG. Okay, LG is the short form for log 10, log base 10. Okay, so for example, if today, if you type in log 1000, you can just key in log and then key in 1000. You will get 3. So I'm going to draw the box, log 1, 0, 0, 0, and press equal. You get 3. It will show you 3. Why? Because 10 cubed equals to 1000. Okay, so the calculator value, the calculator default base is log 3. Sorry, log 3, log 10. It will always be log 10. Okay, always remember that. So using this idea, how do we put it in the calculator for solving other values and other bases? So therefore, in this calculator, all the numbers are all 10. So all we need to do is to take the value log 81. So we just key in log 81. It will be regarded as log base 10 argument 81 divided by log 3, which is log base 10 argument 3, like that. So if you guys can see the screen, it will look like this. Okay, so log 81 divided by log 3. This is what you'll get. And then when you press equal, it will show you 4. This is how you all use your logarithms and using a calculator to solve for values. Okay, of course, like I mentioned, it won't be so nice all the time. Okay, so they will give you decimals, they will give you like ugly values and all that stuff. Okay, if there's a chance or if there's a need for you all to go and solve it. Okay. So you all just need to type in so for example, you want to solve for log 381. So how do we key in again? I write down the calculator steps. So log 81. Okay, right, log 81 divided by log 3 equal. Okay, and then you will get 4. Like that. Okay, hope this clarifies on the log and the pressing of calculator. This allows us to solve for evaluate for values. So always remember, if you have a base and you have an argument like that, that means a value can be evaluated. Okay, a lot of people when it's a very common sense thing. But the thing is that people get stuck because they forgot about this. They forgot that this log 381 or whatever number, it can be like log 400, it can be log 7 1/4. As long as there is a number, there is a base, and there is the argument, these functions these logarithms all of these can be solved, and a proper value will appear. It will appear, whether is it a decimal, whether it's a fraction, whether it's a whole number, but these are concrete values. A lot of people forget about it. They leave it like that. Then they ask how, and then the how will come like that. Okay, so once you see all this, it means it can be solved for a value. It's either you simplify and then you solve it, or you can solve it straight up like this. Okay, so don't get confused and don't miss out on these important details, even though it's very fundamental, but it must be known. This one must be known. Okay, whenever you see a base, an argument that is known, it means you can solve for a value. Okay, let's not forget that. Okay, and so with all these things in mind, we are ready to go into addition, subtraction, multiplication, and division of different things. Okay? Okay, so for addition, as we know that addition and multiplication are always like good friends. So in this laws as well, right, it's going to be even more evident. So for example, if today I have log A, I just write LG lah, just for convenience sake. Okay, log A plus log B. As long as they have the same base, FYI, they must have the same base, is equals to log AB. So what happens is that the things in the bracket here gets multiplied together. Okay, log A, I don't want 4. Log A plus log B is log AB. That means you can multiply the functions together. You can multiply the A and B together to get AB. But all of these must have the same base. That's why I put log, same base. Okay. So same thing. So log A minus log B is equals to log A divided by B. Okay. In fact, these are the two main. The rest is just the same, just derivations of this. There is nothing else to it actually. 1b bk log kk log b bk log bb1 b1 0. Yeah, really, that's all. Okay. But they do indicate that the base, right, that the base that's being used, right, must always be positive. Okay, this one quite important. So in addition to all of this in the front here, the base, I don't use the word A because A has been used in many different places. So the base must always be more than 0, but not equal to 1. Okay. So this is just relating addition to multiplication, subtraction to division. That's all. Okay. Let me see. I can get some questions. Some basic ones. Some basic ones we can pick up from here. Log. Logarithms. I mean, it's okay. Hang on, get my questions. Okay, let's get some questions. Log. Log is fun, log. My wife says no. Why? Log is fun. No? So sad. Log is fun, really, log is fun. No. Hey, come on. 不要误人子弟。
But can pass.
Can pass lah. Confirm can pass one lah. I teach already, confirm can pass lah. Can A one, you see? My wife say can A one. If my wife say can A, means can A. Hey. Okay, I'm going to just share some basic questions. What is a lot of basics? Okay, give me some basics. Have. Okay, basic questions. Okay, so they say evaluate the following without using a calculator. So imagine we have log base 324 minus log 4 plus log 1. Interesting, huh? So you got this one. Okay, so first of all, let's look at each of these terms first, and then we see whether is there anything that we can remove or simplify whatsoever. Let's look at this one. We saw something very familiar. This is log 3(1). That means I go back to recall. This is a value that I can evaluate. It's 3 to the power of something gives me 1. 3 to the power of something gives me 1. And what is that? This must be 0. This one confirm is 0. So that means technically this term is useless to me. This term is useless to me. I can just strike it off. Okay? Simple as that. This is the first one. Hang on. Okay, so the third term, right, is redundant. So I didn't do anything at all. So I only focus on log 3,324 and minus log 3,4. So this one is minus. What does it mean? It means, right, and we check the base is the same. So we are good to go. So that means it's log 3. I can combine the 324 and 4 together, which is 324 divided by 4. Which is, I can evaluate the value, which is 81. Dude, we are back to the same thing. 4. Log 381 was what we used as an example, right? And there we go. Okay, so going back to the example here, this is exactly what we are going to do. Okay? Okay, let's move on. The second question, maybe let's have something different now. Okay, log 125 plus log 8 plus log 464. You do notice that now you see that the base are actually different. One is LG. LG means log base 10. Okay, this is important. Log means LG means LOG base 10. LG equals to LOG base 10. So you can see from here, the 125 and the 8 can come together. So let's combine these two first, which is log 125 times 8. Okay, now log 464. Isn't this quite familiar? Means what? Let's recall again. Means 4 to the power of something. Remember, log is about finding a power. 4 to the power of something gives me 64. And what's that number? 3. Because we recall that 4 cubed is 64. Therefore, this is actually 3. Okay? So let's continue to find. So 125 times 8 is 1000 plus 3. Remember that we mentioned that LG means log base 10. So in fact, I can just rewrite it lah. If I want, okay, to show you guys more clearly, I write it here. LOG 10, argument 100. And once again, 10 to the power of something gives me 1000, which is what? 3. So 3 plus 3 gives me what? 6. 6 is my answer. So from here, you see that we have already employed the different rules that we have shared previously. Number one, we have this one, which is log 3(1), which is 0. Then we know that log 464 can be evaluated to be a value which is 3. Then numbers that is of the same base can be multiplied or divided, depending on whether it's a plus or minus. Here is in this example, it's a minus. Here in this example, it's a plus. Okay? Okay, let's go through a few more. Okay, log LOG 4, 9 over 20 plus log 4, 65 over 13 minus 2 log 4, 3. Same thing, evaluate without using a calculator. From here, how to find. Okay, so as you can see from here, all of them are in log 4. So okay, that's a good first step. Let me look at the front two. These two are both log 4. So what I can do together? Let's look at what's in the bracket first. If we look closely, 65 over 30 is how many? 65 over 30 is 5. So it's actually log 4, 5. Okay? So can we actually, so from here you can see that it's now having the same base and it's connected through plus and minuses. It's connected through plus and minuses, right? We can actually multiply and divide them together already. Okay, same thing from left to right. So how do we do it? So it's log 4, 9 over 20 plus multiply by 5. And then over here, as you can see from the last term here, what happens is 2 log 4, 3. Remember that is how we talk about moving the base to the front as multiplier. We can do the reverse and put it back as well. So in fact, this is actually log 4, 3 squared, which is 9. Okay, so this thing is minus log 4, 9. So the log 4 is there. I want to take out the 9. The 9 comes here, which divided by like that. Okay, so from here, I can also divide by 9 to be 1 over 9 because this helps me in my cancellation. So here my 9 and 9 can cancel. So I'm left with what? I'm left with 5 and 20. That gives me 1/4. You can see it's log 4. My argument is 1/4. So what's my answer now? That means 4 to the power of something gives me 1/4, which is -1. This is my answer. So you see, even though the answer, the question give you a lot of weird ass functions and numbers and bases and stuff, but the answer, if you solve it correctly, it will arrive at a very nice answer. So not to worry on this one. Okay. Okay, the next one is interesting because now we have a new set of issues. But I will show you guys that it's exactly the same thing and the same approach on how we look at real numbers. Okay, 5 log base a square root a minus 3 log base a 1 over a. Okay, so we must always identify the base first. The base is a. For both terms, the base is a. So we are good to go. Okay, identify the base first. Now, let's look at the first term. Log a square root a. Interesting, or square root here. What does square root means? Okay, for those of you who don't know, and those of you who forgot your indices, always remember, square root a is always a to the power of half. Always remember that, because this is called square root. So it's a to the power of half. If it's cube root, let's say it's cube root, it's a to the power of 1/3. So you can conveniently use the square root sign like a 1 over. If there's no numbers, means square root, means 1 over 2. If it's cube root, 1/3. So if today they give you a cube or a fifth root, a fifth power root, it is just a to the power of 1 over 5. Okay, nothing fanciful. It is just exactly like that. So don't freak out, don't get confused. Okay, so bringing this concept back to this question, so it'll be 5 log a. Let us write it over here like this first before I do anything else. And same thing, let's look at the next term. 3 log a. This is 1 over a. Can I also rewrite this as -1? Because a to the power of -1, that's reciprocal. So same thing, you see, now everything is nicely done, but I want to shift my powers to the front as a multiplier. So what happens if there is already a multiplier in front? You can multiply the numbers together. So it becomes 5 over 2. Okay, I write it clearer. So it's actually half times 5 log a. Okay, same thing for the -1. -1 bring to the front, it becomes -3. Okay, so it's actually, how should I write it? Plus -1 multiplied by -3 log a. Okay, so over here, this is half. Log AA is what? Log AA is 1, so it's just 5. This is plus 3. Log AA is what? Log AA is 1. So this is 1. This is 1. So I'm left with this. So it's just 5 over 2 plus 3, which is 15 over 2. No, not 15 over 2. This is 2.5, 2.5 plus 3, 5.5, 11 over 2. Okay, so you see that even though there are A's in the question, ultimately if there is no A in the final answer, means there's no A in the final answer lah. So we don't need to be too freaked out over it. Hey, where's the A? Where's the A? Where's the A? Where's the A? If there's no A to be solved, there is no A to be solved. You can cancel them out to get a nice value. Okay. I want to see there's one that is the change of base or whatsoever. 没有 change of base. Change of base 应该在后面，应该 should be at the back. Should be at the back. But nevertheless, let's use this to solve a few more questions first. Before we talk about change of base, there's still a lot more things that we can talk about. Okay. So of course they will extend it even further. Now all these previous questions are just testing our understanding about how the powers work and how the powers can be brought over to multiplying to being a multiplier and the basic laws. A1 is 0, AA is 1, all these things. Okay, this is still testing on the basic laws and understanding. Okay, so as we take a slightly step higher, they will give you things like this. They will give you a given log function. So for example, they say that log base m 2 equals to x and log base m 3 equals to y. Okay, express something. So log square root 2 over 9m in terms of x and y. In terms of x and y. Okay, so this is something that's different already. They are using the same things that we have did over at the top. It's exactly the same things. But now you need to look at the new function and see how can we fit in our x and y. That's the most important part. Okay, so let's open up and see. So log m square root 2 over 9m. Okay, so you can see this is a fraction. A fraction means like the numerator divided by the denominator. And this means that it can be separated out to be and connected with minus sign. It looks like this. The top minus the bottom. It can be taken out like this. Okay? And now from here, we can look at it individually. This is much more easier. 9m, like that. Okay? So continue. So this is log m. This is 2 power of half. Remember just now I talked about the half, the square root thing. And over here is log 9m. 9m is multiplied. Means I can take it out and make it to two different things, which is log m9 and log mm. It can be done as well. So for safety's sake, I always put in a square bracket to ensure that all of these things are within log m9m. It's not, it hasn't affected any changes with the minus sign yet. So I will always put it in a bracket to make sure I'm clear. So I shift the half in front for log m2. So log m2. Log m9. What's log m9? I don't know what's log m9, but I know what's log m3. So what can I do? I change the 9 to 3 square log. So log m, so this one becomes 3 square. Log mm is what? 1. Okay, this tells us it's 1 already. Let's continue. So this is half. So what's log m2? X minus, and this one we bring the 2 from the power to the multiplier. So 2 log m3 plus 1. Continue. You see, every time in my step, right, I'm only doing one thing at a time. Can you do all at once? Sure, no problem. But for me, for clarity, I would want to do it one by one to show you guys what am I working on at each point in time. So this x over 2, This is 2. Log is log M3. Log M3 given to us already 1. It is y. Like that. So if I were to expand everything out, it will be x over 2 minus 2y minus 1. This is my answer. Okay, and also I will highlight to you guys at which step what am I doing each. So this one, I break it down here. Then this is log M2. Okay, and here I bring it down the power, and then I evaluated both at the same time. Okay, same thing for this one. This is log 2x. This is log 2m3. Okay, the reorganizing from half x to x over 2 is the same thing, so don't get confused. So this is log 2y, and then I open up. Okay, okay. So even though, as you can see, the answer is quite foreign to you, it's quite foreign to you as compared to what we have in front. However, we have to accept that this is a correct answer. And the only way to ensure that your final result is correct is ensuring that you have done every step correctly, allowing you to get the final answer. Otherwise, you will not know. Because there's no way I can verify this. It's quite difficult to do the reverse and go back. It's very difficult really. But I want to make it a proper point that every step, we are very cautious in allocating the power, then the multiplier, so on and so forth. So all these things are very clear. Okay. Okay, let's look at one more. So with all this expression in mind, with the solving in mind, we can also start to solve equations of it. That means you solve for the unknown value of like that. Okay, so from here, how do we solve? First, we ensure that the terms that we have here is a log 5. Log 5, log 5. Okay, all is good. That means what? That means the x and x minus 4 can be combined together and make it into a division. But however, in order to do that, I cannot just throw the 2 alone. I cannot just throw the 2 alone. So what I need to do first, I need to bring my 2 back to its position as an exponent, which is x squared. Like that. So from here, can we go and solve already? Yes, we can. So I combine the two functions together, which is x squared over x minus 4, which is 2. Okay, you notice that I don't really need to change the 2 to become log 5. A lot of schools and teachers does that. That means what they do is, change to same base, so they will change 2 to log 5 25. I don't see a need to. There's no need to, and you might convert it wrongly also. So personally, I don't recommend this. Okay, so from here, right, what they do, right, is they will just convert this to log 5 25. Convert this to log 5 25, like that. Then this will be log 5 25. So that means I can compare the two sides, both is log 5, That means those in the bracket and 25 is the same thing, Personally, I don't like to work on this approach because it actually makes people forget about the original usage and the application of a logarithm function. I like to see it like that. So log 5 something is 2. That means same thing, I go back to my 2 points. Log is about finding the power, and 2 cubed is 8. So 2 cubed is 8. So what does it mean? It means my x squared over x minus 4 equals to 5 squared, which is 25. I prefer to look at it this way. Constantly reminds me that log is this function. So this is the reason why I can teach for so many years and remember the same things, because I choose to stick on the fundamentals and the original definition of what the topic is. I don't go for those methods like log 2, then compare with all these things. Don't need to. It's true, it's correct, but don't need to. Okay? Then students have to find another mental cap to go and convert a integer to a log function. Don't need really, don't need. Don't do that. Don't do that. So from here, continue with you, right? So x squared, I do a cross multiplication, so 25x minus 100. So x squared 25, x squared minus 25x plus 100 gives me 0. Yay. Okay, so from here, this is be rather straightforward already. Okay, let me see if I can observe this out. 25, 100. Okay, from here, we can actually solve it quadratically like a quadratic equation. So 100, what are the factors? 100, 250, 425, 425, 520. 520 is something already. So what I'm marking just now is using the observation method. Okay, so this is 20, this is 5, this is minus, this is minus. For those of you who don't know the observation method, go and refer to my previous videos. I talked about it before. When the coefficient is 1, it's easy for you to straight away observe the coefficients instead of doing your cross factorization. The one is a waste of time. You can observe it immediately, you can do it immediately. Okay, so x equals to 20 or x equals to 5. Very straightforward. So that is my answer already. Then you got to check, are both answers legit and applicable to our question? If x is 20, everything is decent because it will have a definite value. If x is 5, fair enough, this is also a possible value. So therefore, I don't need to reject anything. So x is 20, x is 5, or x is 5. Just like that. Okay. Okay, here's a second question. Log x squared plus 9 equals to 1 plus 2 log x. Okay, this one, same thing. Okay, personally, I will still want to put it all the log to one side and leave the integer on one side, just like how we did in the previous question. Is there a need for me to change it to log something? No. Because technically, I can put it log 10, 10 lah. I can lah, but I don't want to work with so much log functions, so I want to keep it to the minimum. So let's just do it as it is. So log x squared plus 9. I bring the 2 log x over to the left hand side. So 2 log x becomes minus 2 log x. Gives me 1. Same thing. So log x squared plus 9 minus log x squared equals to 1. Okay, step by step, step by step. And now I can combine them together to be x squared plus 9 divided by x squared equals to 1. Okay? So from here, same thing. So log is base 10, right? So 10 to the power of 1 equals to whatever things is over here. So x squared plus 9 over x squared equals to 10 to the power of 1, which is equal to 10. Okay, so x squared plus 9 equals to 10x squared. So this one quite straightforward lah. So 9 equals to 9x squared. So x squared is 1. X equals to plus and minus 1. Okay. Yeah, that's all. So same thing. I have x equals to 1 or x equals to -1. So can both answers be inside in here in this question? Yes, it can. It is okay. Remember, it's okay for the argument to be negative. It's okay if the argument is less than 0. It's okay. If the base is less than 0, it's not okay. But if the argument is 0, it's okay. Wait, let me think about it. -1. 3, 4, 5. Oh wait, it's not okay. Oh, okay. If the argument is less than 0, it's not okay. Not okay. If the exponent is less than 0, it's okay. I got mixed up as well. Okay, so this one must be rejected. So therefore, x is 1. Okay. So even though it seems like a norm, it looks like a very simple quadratic equation. It's just adding a little spice of logarithms to it. No difference. Okay. So let's take I'll just take a small break, and then I'll give you guys a question for y'all to go and solve. Okay, let me just find a question first. I have one question in my content database that talks about logarithms as well. That's why I remembered I got put it here before. Logarithms. Oh, I got quite a few log questions here actually. But this is the basic one. Okay. See if you guys can solve it. Solve for this one. Okay, let's try this. All right, and we are back. Okay. Pretty long break that we took over here, but 10 minutes. Okay. Do you guys manage to stop this? Do you guys manage to stop this? Yeah. Okay. Let me check all my streams are still working. Yep, it's still working. Good. Okay, so let's continue from here. It looks like a very weird ass log question. But if you look at it in the whatever that's happening in the argument itself, because this whole thing over here is the argument. This whole thing here is the argument. So the first thing and the most logical thing that we need to do is to simplify the argument first before we look at the log file. A lot of people rush into looking at the things. Oh, these two are being multiplied, so according to the laws they can be separated and things like that. Then they get all messy and messed up. Will they get the correct answer at the end? Maybe, but I would say definitely a much lower chance, much lower chance, because if things can be simplified, always seek to simplify first. Okay, there are two fractions, there are two things that's being multiplied over here. Each of them has one has two terms, one has one term. But if you look even closely in the argument itself, let's study the argument. Can these things be simplified? Yes, they can. So there's no need for us to rush into, oh, need to separate A plus B is log, because just now someone said log A plus log B is log AB. So I need to separate. No need. Stick to simplify first. Okay, always seek to simplify first. So let's look to simplify whatever is inside first. We got 3 minus 3a plus 2 over a plus 1. Can we simplify it to one fraction first? Yes, we can. Okay, so let's do so. Like that. So this is the first one. Okay. Then over here, I have a squared plus a over 5. A squared plus a over 5. Very obvious. I can take out the a first. That leaves me a plus 1 over 5. Okay, then let's continue. Okay, I still have the square bracket because I'm still not done simplifying it. I can still do the same. So I got 3a plus 3 minus 3a plus 2. So I got 3 minus 2, which is like that. Then I have a plus 1 over 5. Let me check here. Oh, minus 2, sorry. Okay, so from here, what do we have? Log a, 5 over a plus 1 over a times a plus 1 over 5. So you can see there's a lot of cancellation we can do even before talking about log. Okay, a plus 1 gets cancelled out, 5 and 5 get cancelled out. Log a, which is 1. So you see that the log is always at the final thing that we talk about, unless that's the only way out. But in fact, if we look at the question itself, there's a lot of things in the argument that we can do. Focus on working on them first. Don't rush to go and separate things and then, oh, because it's a log question, must separate. No, it's not a must. You do know that it's such a thing. But when do you use it to your best advantage? It's your choice. Okay, if you were to open up log a, then 3 minus 2, then blah 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 blah, you are defeating the question already. You're making things more and more complicated. Ultimately, you will get back the same answer, but you slap yourself by taking like double or triple of time. Not worth it. Not worth it. Okay. So this is one very important question that I saw, that it should be taken note. And all these things should be very, very ingrained to you. Okay. We garner the knowledge along the way, but let's not forget on the basic things that we are supposed to do. All these new knowledge add on. So we internalize already, and then we see what is the best way to go and solve it. Okay. Now let me look at some other questions that we have. Okay. Here's one question. Two log x2 equals to 3 plus log log 2x squared. Solve for x. Solve for x. And if we look at the question itself, this is actually a 4-mark question. 4-mark question means it's quite big already lah. Okay. 4-mark questions we normally advise our students, if you are given 4 marks, that means right, you are supposed to solve it in half the time. Whatever the number of marks that's given to you, right, you are supposed to solve it half the time. That means you are given 4 marks, you should solve it in 2 minutes. If you are given 6 marks, you solve it in 3 minutes. If you are given 1 mark, you should see it instantly. Okay? So always take the number of marks, right, to determine the difficulty of the question and how much things that you are supposed to do. So here there are 4 marks. That means I need to expect myself to solve this within 2 minutes. That means you are supposed to see immediately what to do, so on and so forth. Okay? So from here, what can we do? Okay? So 2 log x2 equals to 3 plus log 2x squared. Okay? So the first thing I want to do is to bring down the 2 from the x squared to a multiplier. So let's go ahead and do that. I keep the rest intact, so because there's no need for me to do the rest of things yet. I'll get this. Okay, now I have a log x2 and a log 2x, which means what? I can employ the what? Change of base. So this is a change of base question. Okay, so when change of base, we can change the log x2 to become 1 over 2 log x, or I can change 2 log 2x to become 1 over log x2. Either one is fine. But for simplicity and for clarity, which one do you choose? I will want my base to be a number. Either way, it's about the same difficulty. It is your choice. So I can make it like this. So 1 over log 2x. So now I have a log 2x to compare with. Change of base. Okay, and let's bring everything over, same thing, all the related that now we got a common term, which is log 2x. That is common. Let's bring everything over to the other side. So I have 2 log 2x minus 2 over log 2x. Okay, plus 3 equals 0. Okay, so from here, how to solve? Okay, so this is where immediately, right, the alarm will ring. What alarm will ring? Do you see that now I have an unknown? This is an unknown, right? X is part of an unknown, log 2x is unknown. And the same unknown appears in the reciprocal. Remember I talked about when do we think about quadratic? There are 2 conditions. The 2 conditions, right, that needs us to immediately switch to quadratic. And what are they? The 2 conditions. Whenever you have an unknown plus a reciprocal of unknown, or you have an unknown with a square of it. It's either unknown and reciprocal or unknown and square. If you see either of these two happening, right, it means it is a quadratic equation by substitution. This one is confirmed one. Okay, so from here, how do we solve? Let me shift this to the side first. And continue from here. That means what do I do from here? From here, right, it's a standard protocol. That means I let y be log 2x. So I sub in 2y minus 2 over y plus 3 equals 0. So from here, what do? I multiply all the terms by y. I'll get 2y squared minus 2 plus 3y equals to 0. I rearrange them in descending powers of y. I'll get this 2y squared plus 3y minus 2 equals to 0. This forms my quadratic equation by substitution. That means I need to solve for the value of y over here and replace it back to the original substitution that we just did. So from here, this 2y, this is y. This is 1, this is 2, this is 1. So this is plus 2 minus 1 equals to 0. So therefore, y is equals to half, or y equals to minus 2. Okay? So from here, let's bring these values back to the original equation. Okay? So log, because we just mentioned that log y equals to log 2x. That was what we substitute in earlier on, right? So now, log 2 to the power of x gives me half. What is x? That means is square root of 2, because it's 2 to the power of half, which is square root 2. That's the first answer. Second answer, log 2x equals to minus 2. That means what is x? X equals to 2 to the power of minus 2, which is 1/4. Okay? 1/4. So there are two answers. One is square root 2, one is 1/4. Okay, important this one. You see, once we have two conditions appearing, these two conditions will appear everywhere. Sometimes it will appear in indices question. Sometimes it will appear in log question. It will appear everywhere. But as long as you see an unknown and a reciprocal of unknown, unknown and a square of unknown, immediately you must know that it is the substitution. Quadratic. You must always think of quadratic. Right? Okay. Okay, next question. Okay. Now you can see that now logarithm questions, right, will actually be integrated into simultaneous equations, like here. Okay, so here we have two equations. We are supposed to solve for x and y. It's a simultaneous equation. So what can we do? Same thing. Name the equations. Always name the equations. If not, you don't know what you're solving. Then you get 1 equal 1, e equal a, like what I mentioned last week. Okay? So from 1, 3 to the power of 1 equals to x minus y, because we have learned it from the very beginning. Therefore, x minus y is 3. Okay? From 2, 5x times 25y equals to 1 over 125. So as you can see from here, there's a couple of things. We got 5, we got 25, we got 125. What's going on? Not to worry. We can convert them all to the same base of 5. So 5x times 5 squared y equals to 1 over 5 cubed. Okay, so from here, let's continue to change it. So 5x. So you can see if the powers are like that, so it's 5 squared, the whole thing to the power of y. the powers will actually multiply together. So it's 5 to the power of 2y equals to 5 to the power of minus 3. So from here, if the two terms are connected by multiplication, the powers can add up. Similarly to logarithms. So x plus 2y equals to minus 3. This is my fourth equation. Okay. So from here, we can compare equation 3 and equation 4. Okay. So you can see that the x and x are common. So immediately, the first thing I want to do is to eliminate the terms already. So I'll take equation 4 minus equation 3. Okay, so I'll take 2y minus y. Okay, that gives me minus 3 minus 3. Minus 3 minus 3. Correct. That gives me minus 6, which is equals to 3y. Therefore, y is negative 2. If y is negative 2, so I sub y equals to negative 2 into, I'll sub into 3 lah. 3 is quite easy, straightforward. X minus y is 3. So therefore, x minus y is 3. So x minus y equals to 3. So x plus 2 is 3. So x equals to 1. So y is 2, x is 1. Okay. The answers are straightforward lah. The equations given are also quite simple. Okay. Let's go for some slightly more difficult questions. Solve. Have. And then let's see how fast can we actually solve them and to identify the things that we need to identify. Okay, let's strive to solve it in speed. Okay, so same thing, we must ensure that every time we do the question, it's not just doing it correctly. So as we do it correctly already, we must continue to build on the speed to ensure that it's faster. Okay, so as you can see, we have a log 5y, log y5. So immediately the first thing I'll do, change of base. So straight away, change of base. So as you can see, immediately from here, what we can see, one is unknown, one is the reciprocal. So immediately you use back the same thing as we did just now, quadratic. Okay. Okay, so we have x plus 2 over x equals to 3. So I have x squared plus 2 equals to 3x. So x squared minus 3x plus 2 equals 0. So same thing, I can factorize out x 1, 2 minus equals 0. So x equals to 1 or 2. Okay, so log 5y equals to 1 or log 5y equals to 2. So this is pretty simple already. Y equals to 5 to the power of 1, which is 5. Or y equals to 5 squared, which is 25. Okay, very straightforward question, done in less than 2 minutes. Because why we are able to do it in less than 2 minutes? Because we immediately can identify this form. And we know immediately how to solve the question. Whether or not they say by using an appropriate substitution or whether they didn't say anything, you must always think quadratic as substitution. Always. Okay, it's always the case. So this is actually, I would say, pretty straightforward. Okay. Okay, let's use one question to round up our logarithms, and then I'll move on to congruence and similarity. This is quite simple. That's why I use the last half an hour to do it. Okay, I know there are some people who are asking about natural logarithms, the ln thing. I'm not going to mention log today. I'm not going to mention ln today because ln is just a special case of log. In general, it's just using a new constant called Euler, which is E. Okay, but the concept, how it works, all these things is exactly the same. So I'm not going to cover on that today. Unless you guys have specific questions that that touches on that one, then I'll touch on it. Okay, let's take a look at this one. Log 8x cubed minus log 4 bracket x minus x squared equals to 1 over log 84. Okay, so from here, you can see that actually this one got log 4, got log 8, but which one do I change? This is 1 over. Okay, there's a couple of situations and a couple of cases that we can start off with. Either we change all the log 8 or we change all the log 4. In this case, I will want to change it to log. Which one you all prefer? either or and either case is fine. Okay, it doesn't matter because since we know about change of base, we know that we can insert any base. So either way is fine. In this case, I will want to keep it to a log. I'm quite undecided because either or is fine. Okay, so before I consider which base do I change to, at least I know that somewhere in the question I need to do a change of base, but maybe not exactly like the first step. So at least I know I look at the question, I have a plan on what to do. I have a plan on what to do, just basic plan on what to do. Okay, so let's look into to rearrange the terms nicely first, then we talk about how to do or how to move around things. Okay, log 8x cubed is there's a 3 in front, so I can just jolly well just push the 3 in front, if I may. And then there's a log 4x minus x squared. This thing is something that I cannot do anything, but what I can do is I can take out the x inside. Okay, so I have x multiplied by 1 minus x. At least this is something I can do. Okay, and then 1 over log 8 4, I can change it to 1 over log 4 8 because it's a reciprocal. Okay, and always remember, do you remember the first thing I said? If there is an argument and there's a base, this means this value can be evaluated. It is a number. It's a number. Okay, so in this case, I realized that log 4 8 is actually 1.5. Or I can say 3 over 2. So let's write it down here first. Okay, let's continue on the rest. What else can we look into? Okay, from here I have a log 4x and then log 4 1 minus x because it's x times 1 minus x. That means I can take it out as if it's like a normal product. Okay, so let's do so. Okay, so from here, what can we do? Can we continue? Yes, we can. Because we know that log 4a is 3 over 2. That means if there's anything that is along the way, if I do the conversion of base and get log base 8 or something, I know that there's a 3 over 2 that can back me up. So in this case, I want to change all to log base 8. Okay, that would be better. Okay. So 3 log base 8x. Okay. This is minus log x over log 4. This is 8 and this is 8. Okay. Plus log 1 minus x over log 4, 8, 8. Yeah, just like that. Okay. Then I can continue to, because there's log 84 at the bottom. Log 84, like I mentioned, it can be solved as value. If log 48 is 3 over 2, log 84 is going to be the reciprocal of it. So it's 2/3. Okay. So I can rewrite everything as such. This is divided, you see, divided by 2/3. Divided by 2/3 is times 3 over 2. So it's actually 3 over 2 times log 8x plus 3 over 2 log 8 1 minus x. Interesting, we got a couple of 3 over 2s that's popping out from nowhere. But will it affect us solving the question? No. So we can still continue to do whatever it is like that. Let's continue to see what's going on. Okay. So from here, I can open them up already since it's a common thing we can do already. So 3 log 8x minus 3 over 2 log 8x. Okay, minus 3 over 2 log 8 1 minus x equals to 3 over 2. Interesting stuff over here now we have. Okay, so as you can see, the first two terms they have the same log 8x. That means what we can do, we can actually do some operations like 3 apples minus 3 over 2 apples. Which what we'll get? I'll get 3 over 2 log 8x minus 3 over 2 log 8 1 minus x equals to 3 over 2. That means you can see that there's a common factor that can strike off already. Okay, so what can we say over here? 3 over 2, I take out it as a common factor, like such, minus 3 over minus log 8 1 minus x equals to 3 over 2. Okay, let me check my streaming over here. Oh, my Facebook hang. Okay, so let's continue from here. Okay, so from here, as you can see, we can start to strike off stuff already. What does it mean? That means log 8x minus log 8 1 minus x equals to 1. Oh, it's going to be hot because 不觉得热？你不觉得热？Okay. So from here, what can we do? We can start to bring the terms back here again. So log 8x over 1 minus x, okay, equals to 1. So x over 1 minus x equals to 8. So x equals to 8 minus 8x. So 9x equals to 8. And therefore, x equals to 8 over 9. Okay, very nice answer that we get here. Okay, so with that, we will come to the end of the logarithms. Okay, let's take a small break first for 5 minutes. Okay. Okay, so we are back. I realized that my Facebook stream hasn't been working well. So let me check whether my Facebook hang again. Yeah, my Facebook hang again. And maybe I will need to delete my Facebook stream today. Facebook hang again. And maybe I will need to delete my Facebook stream today. Facebook hang again. And maybe I will need to delete my Facebook stream today. Facebook hang again. And maybe I will need to delete my Facebook hang. And maybe I will need to delete my lots of echoes going on also. Hang on. Facebook screen is not doing well today.
Maybe.
My external broadcasting software sometimes will hang my screen. So I want to next time I'll prioritize YouTube already. At least YouTube I got record. Facebook 可能有 record. Yeah. So okay, due to time constraint, I won't be going through the rest of the topics already. So I will stop here today. So before we end off today, we just do a quick basic roundup about what we covered today. Number one, we covered on the basic laws of the logarithms. That means all the things that, where did all my stuff go? Probably loading. Should be somewhere up there. Okay, so we cover on the basic laws on the logarithms. And then at the same time, we went through a bit on practice questions to get you guys going in terms and revise on logarithms. Basically, the basic laws and how can we use the different laws to actually apply into the question that we see. And you see that normally, every time when we see an unknown and a reciprocal or unknown and a square, it's an instant bell for you to know that it is time for the substitution and to think quadratic. And always think quadratic. Okay, so before we end off the stream today, I'll just do a quick shout out that upcoming we will be doing our June holidays exam training program. So basically it's targeted for children that is graduating. That means P6 and Sec 4. So we'll be covering a few topics: P6 Maths, Science, Sec 4 E-Maths, Sec 4 E-Maths. So we'll be covering 4 things. So for these 4 things, what we'll be doing is in the June holidays, we'll be doing mock papers. So for mock papers, right, you all can actually either come to our office here or can do it online. So in this 4 or 4.5 hour session, right, the first 2 hours for you all to do your papers. So you all sit under a time environment and go and do. Then after that, we give you a small break. Then after that, when we come back, we will go through the paper on the spot. So for online people, you guys will be hearing it online. So for those of you who are offline, it means you all will come back to here where we open up a meeting room, and then you guys will come together and meet in the meeting room where I'll go through everything with you all. Okay, so it is open to both my duties and public as well. So feel free to let us know which timings that you guys want to book. And then for the payment wise, all the details will be all included in our website and our details itself. Okay, so for this is really a good opportunity for those of you who are looking for a mid-year assessment for yourself to gauge where you are to prepare for the upcoming exams, especially for PSLE and O levels. Okay, so we haven't got a chance to explore the other subjects yet because that's not within our area of expertise. So right now we are targeting on P6 Maths, P6 Science, Sec 4 E-Maths and Sec 4 E-Maths. So it will be on Tuesday to Saturday. 2, 3, 4, 5, 6. So E-Maths paper 1, E-Maths paper 1, E-Maths paper 2, A-Maths paper 1, A-Maths paper 2, and then on Saturday I'll do P6 Maths. Okay, on P6 Science will be done on Friday. Which will be done on Friday. Okay, so grab this opportunity to let your friends know, and maybe for yourself as a duty, if you find it useful, then let us know as well. We will just add it on to your monthly tuition fees. Okay, so with that, we will come to the end of the stream for today. So hope to see you guys next week. Bye bye.